Very good morning to all of you. This is Lakshman Kumar from Yeluru branch, West Godavari. Today I am going to discussing about the today chemistry assignment for junior 10th class students. Okay, in the first one, already you know the assignment for the 10 marks, in which the first Roman 2 questions, each one carry 1 mark. The second Roman 2 questions, each one carry 2 marks. The third Roman only 1 question, that is for the 4 marks. Okay, I am going discussing about this one. State modern periodic law. State modern periodic law. That means what is the modern periodic law? The modern periodic law statement: the physical and chemical properties of the elements are periodic function of their electronic configuration. The physical and chemical properties of the elements are periodic function of their electronic configuration. That means the elements are arranged in the periodic table based on the electronic configuration. The electronic configuration we can write based on the atomic number. So we can say the physical and chemical properties of the elements are periodic function of their electronic configuration or atomic number, but most probably we define it based on the electronic configuration. And here one more thing, what they said, the physical and chemical properties of the elements are the periodic function. What is the meaning? That means when the elements are arranged based on their electronic configuration in the periodic table, the same physical and chemical properties exhibited elements are which is occur after certain interval of time. That is called as the physical and chemical properties of the elements are periodic function of the electronic configuration. Okay, coming to the next question. How many elements are present in fourth period of modern periodic table? If we observe the modern periodic table, in the modern periodic table, in the fourth period, total 18 elements are present. The number of elements present 18 in fourth period. Next, all alkali metals are solids, but hydrogen is a gas with a diatomic molecule. Do you justify the inclusion of hydrogen in first group? Yes. Here the hydrogen atomic number 1, electronic configuration 1s1. So the hydrogen valency is 1. Generally the first group elements and seventh group elements. The first group elements are the alkali metals, the seventh group elements are the halogens. The both are exhibit the same valency. The first group elements exhibit the valency 1. The seventh group elements also exhibit the valency 1. However, which is placed in the first group due to the electronic configuration. Hydrogen configuration 1s1. That's why this is the s block element. That's why which is placed in the first group. Next. An element has atomic number 19. Where would you expect this element in periodic table? Why? Here the atomic number 19 element is the potassium. If you write the electronic configuration for the potassium, electronic configuration of the potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Here the outermost electronic configuration is the 4s1. So here the electron which is present in the s orbital, that means the element which is belongs to the s block, and which is present in the fourth shell, the number of the shell which indicates the period number. So here 4 is present, that's why this element belongs to the fourth period, and the element present in the s orbital, that's why which is belongs to the s block element, and here number of electrons only 1, that's why this is the first group element. That's why the 19 atomic number element potassium which is placed in the periodic table fourth period group 1. Fourth period, group 1. The fifth question. What are the limitations of modern periodic table? How could the modern periodic table overcome the limitations of Mendeleev periodic table? Okay, first I am going to discussing about the what are the limitations of modern periodic table. Okay, ready? Here we observe the anomalous pair of elements. The limitations of the modern periodic table. The first one is the anomalous pair of elements. What is that? Certain elements of highest atomic weight precedes those with lower atomic weight. Mendeleev, what he said in his statement, how he arranged the elements in the periodic table. Mendeleev arranged the elements in the periodic table in the increasing order of their atomic weight. But in the case of the three pair of elements, he reversed the order. First he arranged the higher atomic weight element, after that he arranged the lower atomic weight element. For example, the three pair of elements argon and potassium, next cobalt and nickel, next tellurium and iodine. Tellurium and iodine. He changed the order in the case of the three pair of elements only. Three pair of elements only. Okay, for example here, tellurium atomic weight is 127.6, precedes iodine atomic weight is 126.9. Actually, according to his statement, iodine will come first, later how to write the tellurium. But here the order is changed. In the case of three pair of elements, these are called as anomalous pairs. Next one. Dissimilar elements placed together. Elements with dissimilar properties were placed in same group as subgroups A and B. That means actually the elements which are exhibit the similar properties, these are placed in the one group. But in Mendeleev periodic table, the dissimilar properties exhibited elements. Dissimilar properties means different properties exhibited elements also he placed in the similar group. Okay, for example here, chlorine of 7th A group and manganese is of 7th B. Okay, here chlorine is the non-metal, but manganese is the metal, even though the two elements are placed in the one group only. This is the one of the defect of the Mendeleev. Okay, next. How could the modern periodic table overcome the limitations of the Mendeleev periodic table? Okay, now how it is rectified? The rectification of the problems by modern periodic table. How it is rectified? The periodic law is changed from the atomic weight concept to atomic number concept in the modern periodic classification. Okay, in the modern periodic table, the elements are arranged in the increasing order of their atomic number. But Mendeleev, he arranged the elements in the increasing order of their atomic weight. So here, when the elements are arranged in the increasing order of their atomic weight, the defects of the anomalous pairs is rectified. For example, in the case of the tellurium and iodine. Okay, now when these elements are arranged in the case of atomic number, here we observe. In modern periodic table, justified the atomic numbers of tellurium is 52 and that of iodine is 53. So lower atomic number which is comes first, later joins the higher atomic number. So according to atomic number, which is the correct only. Next, here dissimilar elements are placed in the same group, but here which is rectified. How it is? So the modern periodic table changed their places in the groups and periods. Dissimilar elements were placed in the different groups. So in the modern periodic table, the same properties exhibit elements are placed in a similar group. That's why this problem also rectified. Okay, thank you.